Hi and welcome back to a new video. Already at Computex we were showcasing the prototype of the WireView Pro II. Now today this device is available for pre-order at the Thermal Grizzly webshop. This device was created to early detect and hopefully avoid burning connectors of 12-volt high power or 12-volt 2x6 connectors. Today we will look at the current state of development and also talk about the special warranty that we created that comes with the WireView Pro II. Already early this year we identified this issue on my RTX 5090 Founders Edition where we had a current imbalance on the card where two of the wires were carrying most of the current and were getting really hot. And now we already know half a year later or more than half a year later that almost all the cards that have 12-volt high power connectors or 12-volt 2x6 are affected by melting connectors. So obviously we know it already from the 4090 cases in the past, but also 5080 and we even saw 5070 Ti cases. So basically all the cards that have this connector could theoretically have melting connectors. And I can also talk about this from our experience from Thermal Grizzly because we already offered WireViews in the past, such as the WireView Pro, that also had 12-volt high power connectors, but even there we had cases of melting connectors. And that was the point when we started developing the WireView Pro II with our own connector, which enables the per-pin sensing and also implementing a lot of the safety features. There were a lot of changes from the prototype that you saw at Computex, starting from the own connector, which we didn't have back then, to multiple revisions on the PCB, at the case, firmware, software, all these kind of things. And we now started the production of the first batch, which is 500 pieces normal and reverse, so total 1000 pieces. And we expect for them to be finished in about 6 weeks, so early mid-December we should be able to ship them, and that's also why we decided to offer the pre-orders now. Just a quick overview, we have this nice CNC milled aluminum case with a fan that is sitting inside here, and we changed from OLED to TFT IPS, so much better quality, no burn-in, and also we are able to display colors. We have a button on the side. On the back you can see we removed all the components from previous WireViews to just increase compatibility, and that's also one of the reasons why we created our own connector that is longer than anything you can just get as standard on the market. And then on the bottom you have the connector to the PSU and also other connectors that we will talk about shortly. So just plug in your PSU on the bottom and then plug it into the card, which then automatically also functions as a 90-degree adapter. The card is currently sitting in idle, which you can also see by judging at the power consumption, which you can see on the bottom, 34 watts. The bar that you can see on the bottom left is the indicator of the power draw, so very low, and max would be 600 watts in this case. We can see a fan that is not spinning because the fan is also not spinning. Fan is both temperature and load controlled. So even if the load is low but the temperature would be high for whatever reason, it would spin, or if the load is very high and the temperature is low, it would also spin just to be safe. Then we have those two values that are measured on top right, which is in this case input temperature. So input means the cable on the bottom right here, this 12-volt high power connector, which is 27 degrees. And then we have sense 600 watts. Sense means which kind of cable is detected. There are 300 watts, 450 watts and 600 watts cables, and the WireView is detecting which one is plugged and will display it here. And then on top left, we have these 6 bars, and those are the current bars. You can see it goes from 0 amps to 10 amps. And this is the main view where it would display all this kind of information. I also want to highlight that this is just a current configuration that we have to showcase what the WireView can do. But there will be different designs, not only just this typical black and red Thermal Grizzly design, different color choices, and the overall design might change until the release. The device is fully configurable. There's this button on the side, and each menu that you can see, or each view, has a menu attached. So long press now enters the menu. Here you could select the current scale, which depends on what kind of use case you have. Standard would be 0 to 10 amps, but you could also have a shunt modded card, overclocked card. You want to go higher, 0 to 15, 0 to 20, or you would go lower, which would be, for example, on a 5070 Ti, you would want to display a lower scale. Then you could go from 0 to 5 amps. You could also select what power scale you want to have, that was the bottom left bar, or also which temperature to display, which was previously the in temperature, but you could also display the out temperature, for example. Everything works with either long or short button presses, so short press cycles through it, long press enters the menu and can configure stuff. There's also this simple view, which is focused more towards the power consumption that you can see on top with currently 35 watts. And you can also see the peak values underneath, for example, pin 2 with 0.5 amps, average voltage, 11.9 volt, and the highest temperature. This is probably the most important view, which is the current monitor that displays the per pin current from pin 1 to 6, and also total current on the top right, which is currently about 3 amps. Then there's also a temperature view, which displays in and out temperature. In is this cable, out is the one that goes into the GPU. And then you have TS1, TS2, which are currently not connected. Those are the extra external temperature sensors. This would be a load scenario, see about 580 watts on this card. Quite nice current distribution. Currently, fan is not spinning yet. Now it's getting warmer, fan starts spinning. And now we can see the per pin currents, which are, I would say, between 7.5 and just below 9 amps on this card. So that's just base functionality for now. There's still stuff we're working on. And also I will show more details in a second when we go downstairs. Now the thing is, there are multiple reasons or sources why these connectors might fail. For example, the uneven current distribution. And all of these mechanisms that we know of that we can track, we implemented in the WireView Pro II. This means we are tracking the currents. For example, we know that 9.5 amp is the limit per pin. We're also tracking the voltages and also the different temperatures, as I explained, and input-output temperature, and also external temperature sensors that we are supplying with the device. The temperature sensors are not directly inside the connector, as you might think, so like not inside here, but rather directly underneath the output or the input in this orientation. And then there are those extra temperature sensors. For example, the short one you could directly put into the cable right here, and the long one you could put into the card on the other side into the other connector. But that's something I'm saving for the video once this device is more final. The WireView Pro II will be available in 2 orientations, so normal and reversed. That just means what kind of orientation the output power connector has. It will always function as a 90-degree adapter, so it's plugged into the card, and then the PSU cable comes from the bottom because it puts the least amount of force onto the 12-volt high power cable that comes from the bottom if it's routed correctly. And we put up a compatibility list on the website in the download section of the item, where you can check the compatibility of which card needs normal or reverse orientation. For example, 4090 Founders Edition, you can see the sense pins, the 4 tiny ones, are facing upwards. And we have this tiny ledge for the cable that's facing downwards. This means you will need the normal orientation. But then, for example, 5080, 5090 Astral, you have this tiny cable notch on the top, and you have the 4 tiny sense pins on the bottom. This type of connector will need the reverse orientation. We will keep extending the compatibility list. So far we just did cards where we could visually or physically confirm it, but we could also confirm a few cards that are not compatible. For example, a 5080 Noctua edition, where the connector is just too far recessed and the connector would not be long enough. Or for example, a 5080 or 5090 Founders Edition, where the connector is angled and rotated. That's also a case where the adapter would not fit. Now back to the safety mechanisms that we implemented. I guess the most important one is the per pin sensing and also the possible shutdown feature that is included. So first of all, if anything stays below 9.5 amps, it's fine. You might have a slight current imbalance, that's always the case, but as long as it's within the specification, you're usually fine. Whenever it's exceeding the spec, which is 9.5 amps, you can get a visible and audible alarm. So you get like a message on the display, but you can also hear a beeping noise. And then optionally, you can hook up a cable, and I will show this in a second, where the WireView can trigger shutdown of your system. And now I have a very interesting case to show. And you just saw that we were using this WireView reverse, which is also sitting on this Gigabyte card. And on this Gigabyte card, I was just running Firmark with like 580 watts of power draw, and the current was fine. We were staying below 9 amps, everything within specs. Now we will go downstairs with exactly the same WireView, and I will show you a 5090 Astral where we have a current imbalance, which also shows that it's not just simply the cable or the adapter, but it can also be the card. And that's usually where the user is left alone. But with this, we can detect, and I can just simply prove this right now to you with this case. Fortunately, we have one case in our lab where we have a card that is giving us trouble when it comes to the current distribution. So we can perfectly showcase what is going on. We have here a 5090 Astral with our water block, and we have a WireView Pro II in the reverse orientation. You can see the 12-volt high power cable plugged from the bottom, and also the small cable that is next to it is the Y-splitter cable for the power button. Goes on the bottom into the motherboard. And this Y-splitter cable, so there's this extra connector here, which you would use for attaching your power button of the case. So the power button of the case or the WireView could trigger your system to shut down. That is currently the main view. We see that its system is sitting in idle, so it's like 20 watts power draw of the card. We see the fan is not spinning. We see on sense that a 600 watts cable is detected. And we will now go over to the view with the per pin current sensing. We can see something between 0.2 and 0.4 amps and total not even 2 amps because the card, as I said again, is sitting in idle. I'm unplugging the Y-splitter for now so I can just show you the problem first before it automatically shuts down. And I just launched Firmark. So we can see that pin 1 and pin 2 are out of the spec, and you can also hear the alarm. I'm just quitting out of this for a second so we can show you. Pin 1 and pin 2 are out of spec, so they're above 9.5 amps and the rest is below. So the total power draw is fine, but we have a current imbalance. And this is detected as what we expect. So now closed Firmic again, you can see power draw is down. And I will now attach the Y-splitter cable again. As you can see, the WireView triggered shutdown and shut down the system. But I also want to highlight we're still tweaking the firmware a little bit because right now, as you could see, it's exceeding the limit and then instantly triggers the shutdown to just showcase that it's working. But we are still thinking of what kind of timing to implement that, for example, the alarm starts and you still have a chance to, I don't know, close applications, save whatever you're doing, and then it might shut down after like a minute or so because it won't immediately catch on fire after exceeding the specs for a couple of seconds. So that's stuff we're still fine-tuning where the firmware will still be updated before it's getting released or even after release, and then you can update it yourself. In these kind of scenarios, I would personally recommend that you just try to replug the device multiple times because we know from experience, from plugging a cable multiple times, that the resistance, the contact resistance will change. And it can improve or it can also worsen. It will depend on the case, but the first thing to try would be to just multiple plugs to see if the situation improves or not. But you shouldn't ignore it. Whenever it's reporting above 9.5 amps, above the spec, you should act. If the situation then doesn't improve, you should reach out to us, return your WireView, and we will send you a new one. With a new one, you can just do the same thing again and then check if you're again above 9.5 amps. If you are below 9.5 amps and the connector of the WireView was a problem, everything is fine. You can run your system. But if you will still see above 9.5 amps, like in the case we have downstairs, you would have to probably replace the connector on your card or ask the card vendor if this is a warranty case. And you know, this is, at least from my point of view, the big problem because we have two sides that could potentially cause the problem. We have the card and we have the connector. Might be the cable or the adapter that you might be using, but both in combination might cause a problem or either side. And currently we're only seeing adapter melted, the cable melted, and it's always the adapter or the cable that's getting the blame. But as I could prove to you, it can also be the card side. The thing is just that the plastic on the card side is using a higher temperature range. So it's always the cable side that would melt first, even if the card is causing the problem. And this is not a nice situation for a user because you're just left alone. And that's why we thought of the extended warranty that we implemented together with the WireView Pro II to just give the user safety in case something happens. Another reason why we implemented this extended warranty is because technically it's not possible to detect every failure mechanism. There is also a very special one that just technically can't be detected. You know, the 12-volt high power connector, as annoying as it might be, it's kind of cool that it's self-regulating. So you have the 6 12-volt pins And if you have a very low contact resistance, a good one, it will carry a higher current. If you have a wire with very high contact resistance, it will carry less current. So it's kind of self-regulating. In the normal operation, under full load, you would have about 0.1 watts per pin that is generated in heat. So it's like 1.5 milliohm contact resistance, and you have just above 8 amps if it's very even current. So that's the normal state. But there's also the special thing that can happen if all the contact resistances are bad in an equal way. So in that case, in that scenario, you would see maybe 8 amps across all of the pins, and you would be thinking, oh, that's nice, looks great, everything is fine. But if you have, let's say, 5 milliohm or 10 milliohm, then this could increase from 0.1 watts to like 0.5 watts. And then you're suddenly seeing 3 watts at the connector. And there is no way technically to detect this. You would be looking at this device, you would be like, okay, everything is fine. But then the connector would heat up evenly and might still melt. And even with the load balancing that a lot of people talked about, this is not possible. Like if you load balance the hell out of it, this case would still melt. But these cases exist, as you can see on this WireView Pro that we had. But the thing is, these should be quite rare. And most of the cases should be caught and detected with the per pin sensing. The missing responsibility is still very disappointing for all the buyers in the current situation, for all the consumers, because you might have a melting connector and it could be any of the connections in the system. Like it could be the connector side on the card, it could be the adapter, it could be the cable, it could be the PSU side. That's the same for the case that we just showcased with the Astral. I just want to make that clear. It can be any of the connections in the system, but it also shows that it's not necessarily the connector of the device that you are directly using. And if something melts, what are you doing? You know, the GPU manufacturer will tell you it's a problem of the cable, then you might get a new cable. But then you might still be left with a broken card. And that's why we created the extended warranty for 24 months after buying the WireView Pro II. So if something goes wrong, we hope that nothing goes wrong, but we just can't guarantee it because we know there's specific cases where it might still happen. But in that case, you simply contact us, you send in the WireView with the card, and we are investigating the case. We will replace the WireView, we will solder on a new connector and verify everything if it's working. If everything is repaired, everything is fine, you get the card returned. But for example, if the card is permanently damaged, we will refund you a card with the same performance. And that's, I think, is especially interesting for cards that might already be out of the warranty. For example, if you have a 4080 or 4090, if it melts, you will lose the card. There's not much you can do, or you might have the possibility to get like a repair shop. But if you have this, even if your card is out of warranty, then you send it to us and we will cover it. And with this, it's clear who's responsible and it should be easy for you if something goes wrong. And that's also why we had to slightly adjust the price. When we first showed it at Computex, we were talking about $99, but now we had to increase it to $119.90 without VAT. And that's just because we have to think of a case where we might have to refund a 5090. And that had to be inside the price, but I think it's fair and it should just give you safety in case something still goes wrong. Another topic that is heavily discussed is active load balancing, and it's a thing that we thought about months ago, and we decided not to do it for a specific reason. Now the thing is, you know, the 12-volt high power is kind of a self-regulating environment. It means that, for example, you have the 6 12-volt pins, one of them has a bad contact resistance, then the other 5 will carry most of the current. With active load balancing, you would have to add special circuitry, for example, extra 6 MOSFETs. And what these MOSFETs can do, they can artificially increase the resistance, and with this balance off that you have the same current across all of the wires. Which in this case would mean if you have one pin with a bad contact resistance, the other 5 with a good one would need a worse contact resistance, like a worse overall resistance, to have the same level. Then you would have an even current. That's definitely possible. But it also means that at the same time you are pushing a higher current across the pin with the bad contact resistance than before. And we just don't know if this might cause problems we don't even know about yet. It might cause problems, it might not cause problems, but you know, when 5090s are involved, and these are very expensive, I just don't want to take the risk. It's pretty simple, because to us it's an untested environment, it's an untested case. We just don't know if this helps or even makes things worse. And yeah, you know, we sold hundreds and thousands of WireViews and we saw failure mechanisms and we know what it means if this happens. And from our side, it's just much better to have a monitoring device where you check if there is a problem, then you should fix it. You should not artificially change resistances to maybe push current across a pin that might cause more problems than before. That is a risk we just don't want to do. This is also why the WireView looks the way it does, with a very big aluminum case that acts like a heatsink. We have a fan inside that's spinning at high load and temperature. We added those cutouts in the PCB for ventilation to just dissipate the heat, because from previous WireViews, the smaller ones, these didn't even have the shunt resistors, so they have less circuitry, and these were already getting quite warm. And that's why we know with extra stuff like the 6 additional shunt resistors, it's just gonna get even warmer. And that's why we had to add a fan. And also why we didn't want extra stuff on there like RGB that would add extra heat. And the fan is temperature and load regulated. We wanted to make sure that the fan is not annoying if you're just sitting around in idle, but under load it might be necessary. It will slowly spin up at like 10%, 20%. You can later on, if everything is implemented, also disable it in the menu. Something I wouldn't recommend because I think it's necessary to cool this. But I'm also a friend of giving the user every control you want. But it's something I wouldn't recommend. Another new feature for this WireView is the USB-C connector, which has multiple purposes. First of all, the possibility to update the firmware on the device, because we're constantly updating this with new features. So there will be new features, new things you didn't see yet. We're working on the voltage monitor, on a power graph, and all these kind of things, additional configurations. And this will be, or will help us that we can provide different things to you, also help you debugging. Also, if there is feedback, we can change things for the future. And there is also a software that we are working on. And with this USB-C to USB 2.0 internal header, you just can connect it onto the motherboard and then just connect it inside your system into the PC. One of the most important features for the software will be the access to the logging. There is storage on the WireView Pro II, and it's actively writing to the storage once per minute. That's the plan. And with this, we are able to track 1 full year of permanent use tracked and stored to the device. If you're using this casually, a couple of hours per day, it's probably 3 to 5 years that you can store on the WireView. And you could read this out over the software and just check if values changed over the past months or even years. And especially for us, this would be super useful if something fails, that we can see what was going on in the days or the moments before failure, what happened. And that's also information I plan to share with you guys. Now I want to thank Elmore for all the effort he put into developing this device together with us. And I hope that this is something you appreciate. Please leave feedback down below if you have questions about the device, about the warranty, just let us know. And you can also join the Thermal Grizzly Discord server if you want to, and ask your questions there. I will put the link in the description together with the link for the pre-order. As I said, the first 1,000 units we're expecting to ship mid-December. Everything else, if this happens and we're selling more than that, we're expecting to ship them like end of January or like February if it's more than that. And in that case, I would probably update you on the website. Hope you enjoyed this video. Thanks for tuning in. See you next time. Bye bye.